All right, welcome everybody. Now we're going to look at section 7 of chapter 3, implicit differentiation. Up until now, all of our equations we've been dealing with have been what are called explicit differentiations. Differentiation. Which means we can separate the y's and the x's. So we have y equals 5x squared plus 2x plus 3. We separated the x and y's. Take the derivative of one side and we take the other. Now, implicit differentiation looks at functions where x and y are on the same side. And we'll do one like this in a second, where you don't bother solving for y. For example, like example 1 says, what is that function of? Y squared equal to x. Well, in the past library of functions, we know that this is a parabola because the x squared. So if y is squared, then we go to the side because x can be positive or negative for any one y value. So if we square root both sides there, so we square root both sides here, that cancels the 2, then we get a plus or minus square root of x, which means we have two answers. We have y1 equals the positive square root of x, and then y2 is the negative square root of x. So now we have to take a derivative of that, because we're trying to take a derivative of y squared equals x. So typically what we do is make it explicit, so we solve for y. Now we're going to take a derivative, so we have to rewrite this one as x to the power 1/2. So the derivative of the first side, of this side, bring the power down, which makes it 1/2. So that goes down, and then subtract 1. 1/2 minus 2/2 makes it negative 1/2, which becomes 1/2 x to the power 1/2, which is equal to 1/2 square root of x. That's one side. That's with the positive. Now with the negative side, this would be negative x to the power 1/2. The derivative of the second equation, then it's negative. Power comes down and subtract 1. So we get negative 1/2. So it's negative 1/2 x to the power 1/2, which is negative 1/2 to the radical x. So these are my derivatives. We can do it faster. We can do it cleaner if we use implicit differentiation, where the only rule that we have to follow now, the new rule, is that whenever you take the derivative of y, you have to place a dy dx behind it. That is the only thing that we have to remember to do. Actually, this one is example 2. So no, that one was example 1. Yeah. So example 1 we did. That's the y squared equals x. But now we're gonna look at doing implicitly. So we had y2 equals x. So take the derivative of both sides. The derivative of y squared is 2y. Because we took a derivative of y, we have to put dy dx. Derivative of x is 1. We're solving for dy dx. So divide both sides by 2y. Dy dx is equal to 1 over 2y. But what is y? We have our equation over here. If we square root both sides, those cancel, so we get y equals plus or minus square root of x. So what this becomes is 1 over 2 plus or minus square root of x, which gives us our two answers. 1 over 2 with the positive side, square root of x, and with the negative side, -1, 2 radical x. See, it's a lot faster, a lot cleaner. Example 2. X squared plus y squared equals 25. Let's solve this implicitly. So what this is asking is, find the slope of the circle at 3, -4. It's at the point 3, -4. Right? Remember, what this one's looking for is asking us to find the slope. That's what the question is asking for at this point. So what is the slope? The slope is the first derivative, or dy dx. So that's what we have to solve for. So let's look at this equation and solve for dy dx. Take the derivative of it. That gives us 2x, 2y, but since we took the derivative of y, we have to put a dy dx behind it. Derivative of 25 is 0. Now we have to solve for dy dx. So first, get rid of -2x. 2y dy dx equals -2x. We subtract those. Then we divide both sides by 2y. Those cancel, so we have dy dx is equal to, the 2's cancel, -x over y. Remember, it's at the point 3, -4. So those are our x and y values. X is 3, so it's -3, and Y is -4. The negatives cancel, so we're left with 3/4. That's our slope of the function at that point. Okie doke. Well, that's that one. So now we'll just do the next ones. Let's look at example 3.